Okay, so as we have learned about the instructions in the binary string in the machine language, so we have a simple task is that written the algorithm of hello. If we want to output hello in the screen, how could we write this? How could we write this machine language? Okay, so we can divide the action into 6 steps. Write each character and then stop execution, right? So, and for the first one, write some character. So we choose this 0s1010, which is this one, right? So output the operander as the character. So output the operander as the character. And we use immediate addressing mode, and then we write the H's ASCII number here. Okay, the ASCII number here. Okay, so H's ASCII number. It's similar like this one, okay? For a binary string, it has a corresponding ASCII number. So for this, we need to refer to the ASCII encoding table to check. I will during our class, if you are not going to raise your hands to answer some questions, just stay unmute your mic. Okay, do not unmute your mic. Do not unmute your mic. Okay, so we write H. We can write the binary instructions like this, and in the hexadecimal. Okay, this is the binary. This is the hexadecimal. Okay, so similar for write E, L, L, O. It's similar. The instruction code is same. Just the operander is supposed to be different according to the ASCII encoding approach. You check the ASCII number and find each different instructions. And you can write its hexa instruction, right? Hexa that represents 4 hexa code. That is 4 number are represented as 1 digit. Okay, group 4 and convert them into 1. It's a hexamal digit. And then stop is just a unary instruction, a unary instruction. Okay, so I leave an assignment for you is that for today is that write your name with the machine language. Okay, write your own name with the machine language. Okay, and to submit this assignment before next Friday. Okay, next Friday. Okay, so as we have already talked about what does the instruction format looks like and how does it constructed, and we know how to decode such kind of instruction. Then recall this fetch and execute cycle. Okay, so each time we fetch an instruction and put it in the instruction register, and then we decode the instruction, right? We check its we check its instruction specifier and the operand, the addressing mode and the operand or the address of the operand. We just decode such kind of instruction, right? And then we get the data if we have some operand in the memory. If the addressing mode is not immediate addressing mode, then we need to get some data from the memory, and then we execute the instruction, and we use this program counter to fetch its next instruction, and it's a cycle. Okay, So this is how does the computer work? The fetch execute cycle. How does a computer work in the very, very underlying principle? Okay, so this is about the program counter and the instruction register. It's similar. Okay, such kind of question you will consider this after class. It's quite easy as you has already understand the principles. So this is a PIP-8 simulator, and you can, if you input some kind of such kind of machine language in hexadecimal strings, and then the simulator may output the results. And you can use this simulator through the internet to search such kind of PIP-8 simulator. Okay, and then you input a lot of strings, the binary machine language, to represent, for example, hello or your name or other anything you want to the computer to output. Then it will show the output when the instructions are being executed. Okay. So then that's about the machine language, the binary string of the machine language. So next we are going to learn about this assembly language and also the generation of the software. We also talk about the software development life cycle. And we are going to show some algorithms related to the algorithms. We are not going to show algorithm in this class. We are going to show algorithm next Tuesday about several frequently used, very classic algorithms like searching algorithm and sorting algorithm. You search some numbers in an order, or you want to order in some series of numbers or different items. Anyway, we are going to talk several classic algorithms next class. And today we are going to talk some contents that related to the algorithm. As we said, it includes the top-down design flow or oriented object design flow, and the flow chart and pseudocode and the logic structure. And also this is what we are going to learn next class. And we are also in the following classes, we are also to learn some simple data structure and something about the test and some testing tools. So as we said, when we want to write hello, right? When we write a binary string in the machine language, it's like this. In fact, we can, if our human beings to directly read this, we do not know what these strings represent, what does it mean, right? So we create the assembly language. And the program to write this hello in the assembly language is like this. Okay, so it is much easier than these binary strings, right? So we can understand this and output some characters. So the assembly language is a comment. It is some kind of test written for our human beings for easier reading, okay, which is to explain what is happening right now. Okay, so we can say here the assembly language in this way. This is its instruction specifier. Okay, instruction specifier. That means what instruction it is. And here is the operand. Okay, the operand mode specifier. Here I represents it immediate addressing. D represents direct addressing mode. So here represents its addressing mode. And here represents its operand or the address of the operand. Anyway, this is its instruction or specifier, and this is operand specifier. And here the meaning of each instruction. Anyway, you can see it is much more easier for the human being to read. Okay, so assembly language is a language that use these mnemonic codes to represent these machine language instructions. So as we said earlier, we need assembler. Assembler is a program that reads each of the instructions in this mnemonic form and translate them into the machine language equivalently. Okay, so the assembly language assembler translates this assembly language into this machine language. Okay, so if we show it in the figure, it would be like the programming in the assembly language, then it input to this assembler, and the assembler output to the program in the machine language code, so that the computer can understand such kind of programming language.